Hey guys, so I'm Zach. I'm going to talk a little bit about delivering Go services and some of the changes that we made to bring Go into our stack. So this is me. This is a selfie I took with the sign at the back, which is cool. So I've been programming Go for about 2 years, and I work for a company called Attest. We are a brand intelligence platform, which basically means that we put brands back in touch with the consumers that they focus on and let them make decisions based more on data rather than kind of gut or instinct. So we're a startup. Yeah, it's pretty bold, starting with a kind of a box that says Java in it at a Go meetup. But this is kind of where our technology started. If you're a startup, maybe you have one service, it talks to one database, everything is super simple. It's quite easy to start monolith first because of things like transactionality and stuff. But it's kind of not sustainable. You can't go down this route forever. So we knew that we wanted to split this thing up and eventually end up with more services. So how do you do that? How do you go from that one to the many? How do you kind of get to that fabled end goal of like new service in half an hour, 20 minutes, whatever it is, whatever your metric is? Well, we thought about this, and we decided to invest some time in making it easier. And we came up with a bunch of goals. The first goal is kind of time-based. Essentially, reduce the time it takes you to deliver something. It sounds pretty simple, but yeah. The second thing is that any changes we made, we wanted them to be language agnostic. That basically means that if you bring new technologies into your stack, things like Go, if you're predominantly Java, then all of the toolings and all the improvements you make need to work with that straight away. So with these two goals in mind, we looked at our pipeline. It looks something like this. On one side, you've got the kind of your dev environment where you're writing your code, your IDE, your text editor, whatever. On the other side, you've got kind of your prod or staging, we call it QA, environments. Then you've got the bit in the middle, your pipeline, that kind of links them together. So we thought about these three things. And if we concentrate a little bit on like the left-hand side, on like the prod and staging bit, we think it breaks down into two parts, which are these two, the code and the infrastructure. And then if you look at each one of these, you end up with something like this. If we look at the bottom half, at the infrastructure, this is kind of all the stuff that you get for free. You run some instances, you run a scheduler across the top of them. For us, it's ECS. For lots of people, it's Kubernetes. And then you run a bunch of containers. And then like anything that you deploy just kind of works, and you get that for free. Everything above the line, you end up putting in code. The only box you really care about is the box at the top, your application logic, the thing that you're building. Everything else is just stuff that you need for your service to work, for services to find each other, service discovery, tracing, whatever. So we thought, well, this stuff at the bottom, you get this for free. So we also don't want to rewrite everything that we have from our Java services, again, into Go or into any other language we want to pick. So what if we could take all this stuff and like shove it down into the infrastructure layer and get it for free, like the rest of the things? So that's pretty much what we did. You end up with fewer boxes at the top. Obviously, you have your application logic, the bit that you care about. You probably need a server to run it if it's a web server. And then you probably need some like logging or monitoring-based stuff. But everything else, it'd be nice if you could just get that for free. Well, with the goals in mind and being language agnostic, we chose a bunch of tools to help us with this, which are these ones. So starting from the bottom, our instances all run on EC2. We run the ECS scheduler across the top of them, containers in Docker, nothing special there. Service discovery console works quite well. And then this one, some of you probably recognize, this is the Linkerd logo. So Linkerd is technically a service mesh, but you can think of it kind of like a proxy that sits next to all of your services, and all of your requests go through Linkerd on one end and like pop out of Linkerd on the other end. And this gives you like a lot of power around things. When you have kind of end-to-end through Linkerd, you can do a bunch of stuff for free. You get TLS for free, you get circuit breaking and connection pooling for free, you get distributed tracing for free. So that was pretty cool. And then obviously all of the code written in Go. The other thing is that all of the boxes kind of like highlighted in light gray are technologies written in Go. So now like more than half of our stack actually ended up being Go, which is kind of cool. So there's still a bit too much stuff kind of up there at the top that's not your application logic that you still have to write. So we kind of failed on the language agnostic goal here, but we spent some time investing in that as well. And this is where you have service templates. So, well, what is one of those? It's basically all of the stuff that you need for your service. Yeah, it covers the fundamentals out of the box. It's basically all of the things you need to run your service, maybe as a web service or whatever. They are a bunch of shared libraries, so be super careful if you create any kind of like shared code, because anyone who's had to update more than one thing at once is horrible, especially if you're aiming for hundreds of services rather than like tens or one. So what are they? Well, for us, they break down into two packages in Go. We have one called service. This basically defines a web service. It has all the things you need to run it. Think of this as a bit like a web framework. The martinis, the Go kits, the gizmos, whatever, or all of the other like alcohol-based web frameworks that there are, because they all are. The other one is resource. Resource is a little bit different. Resource basically is the most shared stuff that we have. It kind of controls database connections, authentication with AWS services, all of the stuff that you kind of need, but it's kind of flaky and lives on the outside, but you don't want to rewrite, so probably just share it and hope for the best. So you've got your service, and with some of the tools that we thought about that we have in prod in mind, we obviously wrap it in a container, nothing special there, and then make the best use we can of everything Docker Hub. So run our databases in containers, only in dev, because don't do that, it's horrible. And then Docker provides other tooling for you that you can kind of use and get for free. So Docker has some networking built into it. So you can connect all of your containers to a Docker network, and it will do all of the things that you get in prod in your dev environment for free for you. So it will do service discovery and like hostname resolution based just on the container name, which works really well. Makes configuring things much simpler. And then maybe you have like another service, whatever, and they can all find each other. So how do we do that? Well, instead of having like a 10-page long Docker run command, Docker gives you this. This is a YAML file. It comes from the Docker Compose tool, which is part of the Docker toolbox. And it kind of splits into three parts. The first part is kind of like the setup stuff. You can like inject environment variables. You can set some ports that your things run on, whatever. The other part is the networking. So here we attach all of our containers to this this network. We call it a test default, and we define it as an external network, which means it lives kind of outside this single Docker Compose file. That means that if you have multiple repos that are all defining one of these, they don't all try and like own the network that they create. When you Docker Compose up, which like start everything that I know about in this file, it will try and create that thing. So you basically say don't, it's external. Yeah, so the eagle-eyed among you will notice that we actually specify a custom Docker file in this compose. Well, why is that? Well, this is why. You can statically compile Go. That's nothing new, really. But what's cool is you can put it in a Scratch container, which is 0 bytes to start with. So now pretty much your binary is your container. And then you obviously add it in and run it. That's fine. So this bottom one is the one that we run in prod. Also to note, if you do that, probably add some root certificates, because if you try and ever do anything over TLS, everything dies and it's horrible. The top one, a bit more interesting. This one we copy basically all of our code for a single service into the container, and then we use a live reload utility called Gin, which basically rebuilds and restarts the service that you're working on each time you make a code change, which is pretty cool. And then we can also enable a bunch of other things like the race detector or like set ports for it to run on, whatever. So we saw this. Now, this is a bit unrealistic because you don't have two services. You're aiming for hundreds. And eventually you're going to get to the point where you can't run hundreds on your computer all at the same time. So this is where another one of the tools that we kind of brought into our stack come in. Again, you can replace that one container or whatever, tens, with Linkerd. And Linkerd will do that kind of proxying for you. So now you can run like all of your things in some kind of cloud-based dev staging environment. And your service will be able to talk to those things as if you're running them all on the same computer, which is pretty cool. So we looked at this as well, and we covered a little bit about like the left-hand side and your dev environment and the things you do there, and a little bit about the right-hand side. Well, my way around, and not so much about the pipeline. I guess the pipeline is almost like the most important bit. It's the kind of the bit that links all of like where you write your code and where you run it, and that's the kind of the bit that we thought about optimizing the most. So how? Well, this guy. I know lots of mixed feelings about this. I'm a big fan. I'm going to say that. I'm going to hold my hands up and say that. I think Jenkins is great. So this is Jenkins. It's obviously a CI or CD tool. And Jenkins is really great because it lets you basically define all of your build steps for your projects as code. So you create this one file. It's called a Jenkins file. It lives in each of your repos or each of your deployables or whatever. And it defines the steps to build that service. So what does that look like? Well, something like this. I know there's like a lot going on this slide, but what's really interesting is what there's not here. There's no shell scripts, there's no like build commands, there's no low-level interaction with the computer that Jenkins is running on. Jenkins lets you define a library, which is like the second line, the @library. And that basically imports a bunch of functions, and you can share those functions across all of your Jenkins files. So now, like building your services or like deploying them is like a function call. So there's like one to set up, one to build. Like deploying a service to QA is like a function called deploy QA, and you pass in which service and which version. It allows you to just like basically have one way of deploying any version to any environment straight away. And that's shared across every service that you have. So even if you have 200, you don't have to do this thing 200 times. And then you like change something about your infrastructure, you change it in one place, and everything just works. It works out really well. So everything is kind of like a top-level function. And then like this, success can like call into Slack or whatever and tell you that everything's great and you're amazing. So I spoke a little bit about repos. Let's talk about monorepo. If you thought my opinions on Jenkins were unpopular, I know in Go circles, monorepo is like a big thing. Everyone loves it. Everyone, like Google does it, so it must be great. And I was one of its biggest advocates. I thought monorepo was really great. But we actually, we had something like this. We had our two service templates that we spoke about, resource and service. So they're kind of some like shared libraries. You can't really deploy them. And then we had like all of our deployables, services. And they would all live inside this repo under our GitHub organization. And everything was great. Except we actually ripped it apart and split them into their own individual repositories. But why? That seems counterintuitive. Well, the short answer is tooling, and the long answer is this, dep. So dep, Go has had a bunch of like dependency management issues for a while, and the community, it feels like, is trying to focus around one thing. So dep is the official experiment for dependency management. The way it works is you basically define a bunch of files, and your dep manages a bunch of files for you and takes all of your code, all of your dependencies, and puts them in the vendor folder. That's nothing new. Like, tools have been doing that for ages. But where do you put your vendor folder? Where do you put like the level of specificity that you need? So you could put it at top level. You could put it at like repository level, so this bottom one. But then like all of your services have the same versions of every dependency. So that's kind of horrible. Like, what if you want to update one and not the others? So, all right, okay, we'll put it in the deployables. But then, if your deployables, like maybe count service, relies on the service and resource packages, then you're vendoring stuff from the same repository into a nested subdirectory in the same repository, which kind of goes against all of the good things about having a monorepo anyway. It just feels horrible. You end up with things that are like either like this, where service ends up in there, which is definitely wrong, or like this, which is also wrong. You don't really want either of those two situations. You basically want a tool that could handle this for you, but there isn't one.
But dep doesn't vendor stuff that's in the same repository.
It does. If you have, okay, we'll try it afterwards. Yeah.
I wrote something.
Oh, awesome. Well, you can, if you.
Vendor stuff if it's in the same repository.
Okay, you should definitely show us because I'd be really interested about that because it'll save us loads of time. So.
Like for this exact problem, right? This is a
Okay.
terrible idea to vendor
Yeah, exactly, yeah. So that's cool. But the only way that I found to fix it was either making it ignored or doing something else, because it would be added as a bunch of dependencies. Importing it.
Yeah.
So it ends up in the go package.toml file. When you in it, it ends up in there, and then everything after that, you either explicitly, sorry?
To import your resource directory, what import path?
Oh, the absolute GitHub path.
Okay, that's really fun.
Oh, well, yeah. Well, let's go. I'd be really interested about that, so thank you. So yeah, I mean, you split it apart and it becomes really obvious, like don't vendor the code inside its own repository. So we did that and it worked much better. The other second thing is Jenkins. When we set out kind of on this journey of bringing Go into our stack, we knew that everything had to work as well or better than it currently did. And all of our Java services work really well with Jenkins. When you start having monorepo, you end up with commands like this. So anyone who's like super good at Git or Bash, or like a combination of the two, will tell you that this outputs something like this. It basically works out which of the nested subdirectories or like packages, top-level packages in your monorepo have changed based on the last commit. No one wants to do that to work out what to build. I mean, it works fine if you're just doing deployables, like you work out that these two deployables have changed and then like maybe rebuild them and redeploy them, whatever. But when you end up with like shared code, like service, like a shared library that's changed, then you have to work out also on top of that, like all of the dependencies between all of your either packages or services, and then like follow that all the way down the kind of tree and build the ones at the bottom, which ends up as horrible. There are people, I think it's DigitalOcean, might have been Dropbox, who build tools that did almost exactly this for you, but they haven't, hey.
Sorry to keep interrupting.
No, not at all, go for it.
Have you tried Bazel?
Bazel?
It does exactly that for you.
Oh, interesting. Is that a build tool or?
It's Google's build tool.
Oh, cool. Nice. Well, Jenkins is what we got. It works really well. Yeah, well, we chose Jenkins for a bunch of other reasons, like the shared library.
I mean, you would have Jenkins trigger Bazel.
Okay, so.
You could query Bazel to say what's changed, and it will tell you what's redeployed.
Oh, nice. So you have to have two build tools now instead of one.
Well, I mean, you still use Go
Okay.
build, right? So it's
Well, anyway, we tried to avoid doing this. There's a bunch of different ways to do that. Not doing it is one of those ways, which works quite well. So it wouldn't be fair without a couple of gotchas. It kind of boiled down to two parts. The theme here is cheap but not free. We had something like this, which has its own problems, like no request should live for 40 seconds. You should definitely kill it before that. But we did have one, and we investigated it. It was brought up by a bunch of our load tests, which kind of run on a cycle. So we kind of knew the flows that were causing it. So we looked into it, and we broke out a bunch of tracing tools. Obviously, the first one is the GoTrace tool. So this like hilariously small graph tells you like as much nothing as it told us, apart from like it was running on a box with 2 cores, which is actually something to keep in mind. Basically, all of our services run on an instance. There's basically 3 slots, the way we set up our CPU shares and memory shares for Docker. It's basically 3 slots on each of our instances, and this service was taking up one of them. So if you bear in mind that the time along the top is like real elapsed time, and your service is limited to 1/3 of the resources of the instance that it's running on, you'd expect, actually, this graph that looks quite sparse and empty, like it's not really doing much, but it's not. If you take all of those bars and like squish them to one end, you'd probably fill up more than 1/3 of your elapsed time. So it can be quite misleading when you look at tools like this. This was probably running at like pretty high on the number of resources that was allowed, but the way that they were scheduled means that you don't necessarily see that straight away. So this other like hilariously small graph is the blocking profile from pprof. The only interesting thing here is that all roads point to runtime.selectgo. And then we did one more, which is the CPU profile. Again, nothing that interesting apart from this kind of outlier on the left, syscall.syscall. So these two. This is what we ended up with. We decided these were the culprits. Interestingly, just before going down finding this problem, we just upgraded to Go version 1.9. So obviously, the first thing you do is like Google, and if Stack Overflow doesn't tell you the answer, you rely on GitHub issues. So we found this one. which seems to say that the runtime, the implementation of select, which is runtime.selectGo, is unfair. I guess the first rule of like debugging is if you find a bug, it's definitely in your code and not in the language or any of the libraries. And that's probably also like the second and third and fourth rule. It's your fault, I'm sorry. So yeah, it wasn't this. Spoilers. It was actually, that endpoint did something like this in a super simplified way. It split out and did two things. Both of them were heavily cached, but also the Go routine that it was originally running on. So it comes in and then like spins off two new Go routines to do these two lookups. But the Go routine that it was originally running on lived on. So you'd end up with this like three-way contention on a two-core machine, which caused some of those problems. So we fixed that. We essentially ripped out the concurrency, and it was much faster. The other one, syscall. Syscall is basically a call into the kernel. It's anything that your operating system provides for you. So the only thing that we do with that, we don't do any file I/O, we don't do anything like that. So the only thing that we do have is logging. We log to standard out with logrus, one of many logging packages. This solved it. Just buffer the writes. Worked quite well. We're quite log heavy, and just doing something simple like this meant that we're not doing like a syscall every single time that you write a log message, which makes an enormous difference. So what difference did that actually make? Well, this doesn't tell you much. Well, the blue in the background is before, the red in the foreground is after. The only reason it goes in this kind of like 3 ripple spike diagram is the way that our load tests are set up. It's just the flow of how the requests come in. The interesting thing here is that before it was like loads, and now like the average response time, which is what this is showing, doesn't really get off the bottom axis, which is cool. So what does that look like in numbers? Well, a 200x improvement just from buffering some logs and ripping out some concurrency that you probably didn't need, which is awesome. So ultimately, it boils down to, if you want to bring like a new technology like Go into your stack, find some tools that will make your life easier for you, and it's going to be a much easier sell. These are some of the ones that we used, and some of the ones that worked out really well for us. There are others, as you kindly pointed out. But yeah, if anyone's got any questions on that, I have a minute.
I think Matt's got the throw mic, so we'll see how long if you want to aim it straight at Tom.
He's going. Okay.
Oh, is that
So if anyone hasn't used this one of these before, speak into it. It might work. Probably stand up as well.
Sure. What do you do with all your logs that you collect? Because if it's a large number, do you keep them in the instance? Do you replicate them? Do you send them off somewhere else? And does it pose a different problem in itself?
Yeah, so we use the AWS Logs plugin for Docker, so write everything standard out, and then the AWS Logs plugin ships them all to CloudWatch. It works quite well. Don't have to worry about them.
Hello? Oh. Is that only works when I'm standing? Do you have to pay for that separately, or is it free? Is it per time-based schedule, or is it like per megabyte, etc.?
So you pay per log group, and each log group is kind of relates to your service. So one service, one log group in QA, and one log group in prod. It works, yeah, it's quite good.
Didn't realize this one works. So I noticed you said Linkd. You use Linkd to kind of wire up your development environment or production environment. Is that correct?
Yeah.
Can you just elaborate on that?
Yeah, absolutely.
How did you make that work? It's really interesting.
So in our production environment, we run Linkd once per host. So once essentially on each instance that we're running in that environment. each of our applications is set up with an address, so it knows where to find that linkerd. You can do exactly the same thing locally. So you say, this is where you find linkerd, and then from there, there's a bunch of different ways you can set up that proxy. So it's either it takes part of the path of the request and resolves that into a service, or like takes some headers out of the request and resolves that. Linkerd integrates with loads of different things. One of them is console that we use for service discovery. So you give it some config and you say, this is what I'm going to send you, and then this is where you need to look for that thing, and then it will do the resolution of that name and route the request for you. So it works kind of the same in prod and in QA or dev or whatever. You give it the config, you say, this is my instance of console, and then you say, I want to go to linkerd /service name, and it will work out where that is and then reroute that request.